A violin plot visualizes data distribution. Combining a box plot's summary statistics with a kernel density estimate, it's perfect for comparing the shape and spread of multiple distributions. Using Seaborn's TIPS dataset, we'll demonstrate.
First, a basic violin plot of total_bill by day. We'll create 4 subplots. Second, adding jitter equals true overlays individual data points, revealing exact values within the density. Third, using a palette customizes colors for improved visual distinction between days. Finally, setting *hue equals smoker splits the violins, allowing multivariate analysis to compare bill distributions for smokers versus non-smokers across different days. A violin plot is a method of plotting numeric data. It is similar to a box plot but also shows the probability density of the data at different values. Like a kernel density estimate, the violin shape represents the distribution of the data, with wider sections indicating a higher density of data points and narrower sections indicating lower density. Inside the violin, a miniature box plot or other markers typically represent the median and interquartile range.
Violin plots are particularly useful when you need to compare the distribution of a quantitative variable across different categories of one or more qualitative variables. They excel at revealing multimodality, multiple peaks in the data, skewness, and tails, which a standard box plot might obscure. Use them when you want to understand not just the central tendency and spread but also the complete shape of the data distribution.
The provided Python code demonstrates how to use Seaborn violin plot with the TIPS dataset. It generates 4 subplots to illustrate various features. The code begins by loading the TIPS dataset, a common dataset for demonstrating categorical plots, and sets up a 2x2 grid for plotting using matplotlib, pyplot, subplots. Each subplot then progressively adds more complexity and parameters to the violin plot.
The resulting visual output displays 4 distinct violin plots. The top left plot offers a baseline understanding of bill distributions per day. The top right plot adds clarity to the central quartiles within each distribution and applies a distinct color scheme. The bottom left plot introduces a third variable, smoker, showing how the distribution of total bills varies between smokers and non-smokers on different days through distinct violin shapes and colors. Finally, the bottom right plot uses a split violin for sex and overlays jittered raw data points, allowing for a detailed examination of individual data points' spread and density within each category, complementing the overall distribution shape.